question 1, please. Question 1 is on trying to find a power function. Now I've done enough exams. I guess I've done quite a few already on trying to derive the power function. Hopefully. All right, let me start this off. Maybe you can, let me show you how to do this, okay? So you're testing for you're testing this versus this, where P represents the proportion of defectives, yeah, and Y represents the number of defectives Y represents the number of defectives in a bag of 20 items, and we reject the null hypothesis if Y is greater than or equal to 7 or less than or equal to 1. Right, this is what you're told, and the question is to find the power function for P. Right? Okay. Now remember, guys, if you look at what I taught you guys, you will see that the power function is defined as the probability of rejecting H0 given the value for P. Right? We are doing question 1, guys. If you came late, we are doing question 1. Okay. So this is the probability that Y is greater than or equal to 7 or less than or equal to 1 given the value for P, right? Where Y represents the number of defective items in a bag of 20 items. So now I'm going to use the complement rule. You know the complement rule, that the probability of an event is 1 minus the probability of the complement of the event, right? Now what's the complement of this event, guys? The event that Y is greater than or equal to 7 or less than or equal to 1. The complement of that is the event that Y is between 2. Can you see that, guys? Yeah, this event is the complement of this event, right? Yes. Okay. Now if Y is between 2 and 6, then it can take the values 2, 3, 4, 5 and 6, right? So we can write this as the sum of the probabilities Y equal to I from 2 to 6. Yeah. Now remember, Y is the number of defectives in a bag containing 20 items. So what distribution do you think Y should have? Binomial, exactly. So it's binomial with probability P. So the probability that Y is equal to I is the I'm sure you guys remember this formula, don't you? This is the probability mass function for the binomial distribution, right? Yeah, we did this ages ago. So therefore, the answer to the question is this is the power function of P. Now you are also asked to find pi of P at P equal to 0, 0.2, 0.4, 0.6, 0.8, and 1. Now to do this part, I mean, I'm not going to do this here because I need a calculator and I don't have one. So all you have to do is just sub in these numbers into this formula and find the value for pi of P. So for example, put P equal to 0.2 into this and work out this. So you need a calculator to do that, right? Yeah. And you are also asked to find the significance. You are also asked to find the significance. Now, if you guys remember what I mentioned in the lectures, do you guys remember what a significance level is? I mentioned this, guys, in the lectures. The significance level is the same as, it's alpha, yeah. It's the same as the probability of type 1 error, or alpha. And the probability of type 1 error is simply the probability that we reject the null hypothesis when H0 is true, right? Which is, H0 is true if P is equal to 0.2. So this is simply pi at this. The probability of type 1 error is the value of the power function when P is equal to 0.2, because the null hypothesis says P is equal to 0.2. Yeah. So all you have so the significance level is the same as this. And to work this out, all you have to do is just put in place of these two, put 0.2 and work it out, right? Is that clear, guys, or not? Yeah. So that's question 1, guys. So that's question 1. Are you all okay with this, or you guys okay with this? Yeah. Okay. Can you do question 2, please, now? Question 2. Can you guys, if you can you guys do question 2, please, now? Question 2 on sheet 5. Yeah, because it's type 1 errors, the code will generally. Yeah, because remember, the signal is level probably to type 1 error. Type 1 error is equivalent to rejecting null hypothesis, then it is true. And the null hypothesis is true when p is 0.2. So this is the same as phi at 0.2. Question 2, guys. Question 2. Sheet 1. All right, guys. So you're, in this question, guys, you have this, you have p equal to 0 point versus p equal to 0.2, and we reject the null hypothesis if x is a geometric variable with parameter p, is less than or equal to 5. And you're asked to find the alpha and the beta. Remember, alpha is the probability of type 1 error, and beta is the probability of type 2 error. Okay? So let's try to find alpha first. So it's the probability of rejecting the null hypothesis when it is true, right? So this is the probability that x is less than or equal to 5 when p is equal to 0.1. Now, if x is less than or equal to 5, it can take the values 1, 2, 3, 4, or 5, yeah? Because remember the geometric variable is only defined from 1 onwards, okay? So this is yes, yeah. Now, if you look back in the lecture notes, I think we did this in week one of the course. The probability mass function for the geometric variable is so this is the answer, guys. I mean, of course, you can simplify this, which you have a calculator, you can work this out. All right. So this is the probability of type 1 error, or alpha. Okay. And beta remember, type 2 error is the probability of accepting the null hypothesis when H1 is true. So it's the probability we accept H0 when P is 0.2. Okay. So this is, you can, once again, by the complement rule, you can write this as 1 minus the probability that you reject H0 when P is 0.2. So this is 1 minus the probability that x is less than or equal to 5 when P is 0.2. So this is 1 minus the probability that one minus the sum of the probabilities that x equal to I when P is 0.2, which is 0.2 times 1 minus 0.2 power I minus 1. All right. It's not difficult, is it, guys? I mean, yeah. You guys follow this or not? Yeah. 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 And you guys, if this is okay, can you do question 3, please? To do question 3, you need to use the lecture notes, which the stuff we did yesterday in the lectures. You need to use that to do question 3 and also question 4. If you don't have a copy of the lecture notes, I can give you a spare. I've got one here, I think. Yeah. Yeah. So you need to use this word to do question 3. No, I think the question here is to find the type 2 error. So you just need to find the conflict with type 2 error, which is beta. The same as beta. Yeah, type 2 error is 2, except H0 and H1 is 2. So you need to use this word and the definition of type 2 error. But yeah, this is the rule for rejecting 0. So for yeah, here. You also look at no, you only asked to find the type 2 error, not type 1. It's not. No. It's not. Just find the type 2. Find the type 2 error only. You don't need type 1.
Yeah, for example, when you take like 2 bits out of 2.
Yes, okay. Yeah.
C is for you, right?
You guys did it. Okay. Right, guys. Okay, can you guys listen, please, if you haven't done question 3? Right. Now, the first thing you should figure out is that what is the rule for rejecting the null hypothesis? You are told that the null hypothesis the null hypothesis is mu equal to 0. The alternative is that mu is equal to 4. So if you look in the lecture notes or the scan notes, what is the rule? And you tell me the rule for rejecting null the H0. This is somewhere in the lecture notes, guys. I talked about this yesterday and the day before. Can you see it? No? Can you see this somewhere? If you look at equation 95, equation 95 in the lecture notes, this is what it says. You reject the null hypothesis if this is greater than this, right? I'm using equation 95 because under the alternative hypothesis, 4 is greater than 0, and that's why I'm using the alternative. That's why I'm using this equation, right? Now the question, guys, is to find the probability of type 2 error, right? Which is, as you all know, is the probability of accepting H0 when H1 is true. Okay, this is the definition of type 2 error. Okay, so now this is the rule for rejecting H0. So the accepting will be the complement of this rule, which is root n yeah. Alright, this is the complement of this event. Okay, so what you need to do is to work out this probability. Now this is where the stuff I've been doing comes in, guys. Now the first thing you must realize is that the true population mean. The first thing you must realize is the following: is that x bar has the normal distribution with parameters mu and sigma squared by n. This is stuff we did in week 1 or week 2, guys. You should look back in the notes. You will see this result. Okay, so the first thing you must do is to realize that the true population mean is equal to 4. So I'm gonna you see why I'm doing this, because you see why I'm doing this in a minute. I'm subtracting the true population mean and adding the true population mean so that I didn't make any change. Okay, now I'm going to take this 4 here to the right hand side. Okay, so it will become right. Yeah. Now let me ask you guys. Now condition on the fact that the true population mean is equal to 4. This guy here will have what distribution? To have the standard normal distribution, right? Okay. So so the next step is the probability that n01 is less than or equal to. Okay, here I've dropped the conditioning because I've used the conditioning to argue that this has the standard normal, and therefore we don't need the conditioning anymore. Okay, so this is equal to phi or phi. So that's the answer, guys. It's not so difficult, is it, guys? Yeah. 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 That clear, guys. All right. Can you do the next one, please? Question 4. Question 4 is also you need to use the formula from the lecture notes, and you will know which one. You should know which one it is. similar to question 3, guys. Question 4. Just need to find the correct rejection rule on the nodes. Yeah. So your answer. Okay, man. I did okay. Do you have a question? Yeah, yeah. You should look at the notes. It has the rejection rule, which involves alphabet. Do you have the notes with you? I'll show you.
Yeah, I think it.
It's a good one here. Yeah, anyway, you should look at it. You see that the rejection rule involves alphabet too. Rejection rule involves. I'll do that in a minute. How you guys feel? Okay. All right, guys. Let's see how we can do question 4. All right. The first, the first thing you guys realize is to figure out the rejection rule, and what would it be, guys? Here, what is the rejection rule? Huh? It's in the lecture notes, guys. In this case, what would be the rejection rule?
Isn't it the same except it's absolute value?
Yeah, exactly. So it will be similar, guys. The only difference is that you have an absolute value and alpha by 2 here. So this is, if you look at, guys, I'll show you where this comes from. This is equation equation 92, I guess. If you look at equation 92 in the lecture notes, this is what you have for the rejection rule, right? Now, the question here, guys, is to find the power function. So we want to find the power function at mu, which is the probability of rejecting at 0 given the value for mu. So which is the probability that root n by 2 all right. Remember what I told you yesterday in the lectures. Whenever you have an absolute sign, the first thing you must do is to get rid of it. And so, how do you get rid of the absolute sign like this? All right. If this event is the same as saying that this is greater than this or this is less than this, yeah. Okay. Now, because these two events are mutually exclusive, you can write it as the sum of the probabilities. Yeah. So this follows by mutual exclusiveness of the two events. Right. The next thing to do is you must realize that we are conditioning on the fact that the true population mean is equal to mu. All right. So in order to use the standardization, you're gonna subtract a mu here, and therefore we need to add a mu. Okay. Now the next thing I'm going to do is, similar to before, I'm going to take this to the right hand side and take this to the, sorry guys, to the right hand side. So you will get yeah. Right? You clear so far, guys? Right. The next thing is what I have done many times. Several times now. Now these two guys, you must realize now, have the standard normal distribution, right? This one and this one, right? And therefore, yeah. Now, in this step, you realize that I have dropped the conditioning because the conditioning has been used to argue that these two have the standard normal, and therefore we don't need them anymore, right? Okay, and the final step is you can write this as 1 minus phi as this, and this one as phi at okay. So that completes question 4, guys. Does it make sense, guys, or no? Yeah. Can you do the question 5 now? I know we only got a couple of minutes. Can you have a go at it, please? Just a minute. Just a minute. Can I take this? Can I take this again? You should look at it. You're using this here is mu equal, right? This mu equal to 100, but it's less than 100, right? Okay. Now, if you look at here, you have this one where it's equal to something not equal to, and you have equal to something less than. Yeah? This is less than. This is less than. No, this is less than. Greater. So you should use this one, which is less than, right?
Yeah, that's what I use.
I think you left out a minus sign. All right, guys. Can you do question 5? And yeah, sorry, you have a question 3. Somebody doing it will use 95 because the rejection rule will have 100 in it. The rejection rule will have 100 in it. But when you try to find the probability that you obviously are rejecting when you use 95, you condition on the fact that you use equal to 95. You know what I'm saying? So what you will do is you will this is the correct way. So root n by 62 or something. Root n by 10.
Oh, sorry.
You guys do question 4 and 5 by yourself, and if you can't do it, come and see me in my office. I'm available all day. Right? The same thing, try to do question 5 and 6 by yourself. If you can't do it, just come and see me in my office. You're all set? That's good. Thank you. See you, man. See you.